Guys, can you hear me? Am I audible? Actually, system, it's bit slow, guys. Okay. Yes. Nagireddy, cluster clear, Amar. Good. So yesterday we completed disk management and how to create the additional swap partition, right? Today we'll do how to create the LVMs, logical volume management. Maximum will complete disk management today. From tomorrow onwards, we'll start networking concepts. Okay. Today also class strength is less R. Ah, usually we should have 100 peoples, right? Nagireddy. So only 48 peoples will have today. What will do, man? Peoples there become like that. Huh? So huh? They're still in holiday mode. Huh? Ticket దొరకట్లేదా? Okay. Right, guys. Let's start. So first of all, we'll discuss about theoretical part related to LVM, and then we'll start practical session, right? Right. Yes, guys. LVM, logical volume management. LVM full form, logical volume management. Guys, yesterday, day before yesterday, we discussed about standard partitions. We have on hard disk, we are trying to making multiple slices. That means multiple partition. Can we able to increase the partition size? It's possible. Yes, guys. Can we able to increase the partition size? It's possible. No, right? We have 1 TB hard disk. Can we able to increase this 1 TB as a 2 TB? It's possible. No, right? Like the same way yesterday we did standard partition. If you create the 2 GB partition, we are unable to increase the 2 GB to 4 GB. If you try to increasing the partition size, what will happen in the sense you're going to lose your file system. If you're losing your file system means you're going to lose your data. I hope you got it. So the standard partition, it's not that much worthable in real-time environment, because in real-time environment, people's they try to modifying frequently all the storage. For example, we have now 1 TB storage. So maybe we need to increase this 1 TB to 2 TB in future. Then, so it's a bit difficult to us if you're using standard partitions. So because of that reason, in real-time environment, maximum people they're going to use LVMs, logical volume management. So let's see here. First of all, try to understand the concept. Okay. So let's see, guys, here. For example, assume this, we are trying to starting one small organization, right? Let's see. So while we are trying to starting one small organization, at the time our employee capacity only 10 to 20 people. So we'll have 10 to 20 people. They're working as a developers into our organization. We got a one project. one small project, right? So in our organization, we'll have 10 to 20 people, right? So for them, 1 TB storage space is enough, right, guys? We purchase 1 TB hard disk. Then those 10 to 20 people that try to writing code, those all the codes they're going to store into 1 TB. Maybe after a few months, we got another project, right? So we need to increase our strength. So we'll have 20 peoples now. So we need to recruit 20 more peoples. Total 40 peoples will have now as of now. Maybe after 6 months, maybe after 1 year. Right, guys? Then if you increase the strength, always we need to increase the storage. 1 TB storage, no, it's not enough. I hope you got it right. 1 TB storage, no, it's not enough. We need to increase 1 TB to maybe 2 TB or 4 TB, whatever it may be, according to our requirement. Right, guys? Can we able to increase this 1 TB hard disk to 2 TB? It's possible. It's not possible. So if it is possible, no one they are going to purchase the hard disk. That's it, no? So if you try to increasing 1 TB to 2 TB, then who is going to purchase another hard disk? Right? It's not possible. So this 1 TB, it's like one standard partition. 1 TB, it's like one standard partition. We are unable to increase. According to our requirement, we can able to divide the multiple partition. That is a different story. Already we done day before yesterday. Right, guys? Now we need to increase the size from 1 TB to 2 TB. Then what kind of possibilities will have? How we need to increase the 1 TB to 2 TB? We need to purchase one more TB hard disk. That's it, no? So we are going to purchase one more TB hard disk. Right? So we are going to purchase one more TB hard disk. Right? 2 hard disks. Or otherwise, usually people they are going to purchase 2 TB hard disk. 2 TB it's bit expensive, right? And unnecessary this 1 TB we need to keep into one corner. And we need to transfer the data from 1 TB to 2 TB hard disk. It will take some time. Okay. Instead of purchasing the 2 TB hard disk, what we are going to do in the sense, we are going to purchase one more TB hard disk. Okay, guys. 2 1 TB hard disks will have. Right. Now, we are going to use those both the hard disk. Okay. We are going to use those both the hard disk. Now we are going to create one volume group. Right, guys. We are trying to creating one volume group. Let's see here. 2 different hard disks will have. So we are going to use those both the hard disks. We are trying to creating one volume group. This is called VG, volume group. Okay. So now we are going to add those both the hard disks into this VG. Right, guys. Now 1 TB plus 1 TB, how much? Now this volume group size, it will become 2 TB. I hope you got it, guys. Clear? With the help of this volume group, now we are going to create logical volumes. So what is the use of logical volume? We can able to increase, we can able to reduce the partition size according to our requirement. It's not like this. We need to create 2 TB one partition. If you want, you can create 500 GB. If you want, you can create 1 TB. Your wish. Maximum possibility 2 TB. Maximum possibilities are 2 TB. So we can able to create till 2 TB. But here we are trying to creating only 500 GB. Now, according to our requirement, we are trying to creating 500 GB LVM, logical volume. So at present, 500 GB is enough. Maybe after a few days, we need to increase the storage space from 500 GB to, for example, 800 GB. Without losing the file system, we can able to increase the disk space and we can able to reduce the disk space. I hope you got it, guys, right? So what is the use of LVMs? We can able to increase the disk space without losing the file system. We can able to reduce the disk space without losing the file system. I hope you got it, guys, right? Okay. So for doing the practice, we doesn't have multiple hard disks, right? We have only 40 GB hard disk into our virtual machine. In that 40 GB, 30 GB already we utilize for operating system. Remaining 10 GB will have. Right. So clear. 1500 GB. అర్థం కాల అర్థమైంది చేసుకోవచ్చు. We can able to create 2 LVMs. We can, with the help of this VG, we can able to create the multiple LVMs, right? If you want, you can create one LVM. If you want, you can create multiple LVMs also. Okay, one LVM 500 GB, another LVM 1.5 GB, 1.5 TB. Got it, guys? Like this also you can, but we doesn't have the space to increase. I hope you got it. We have the possibility. We can able to create the multiple LVMs, right? I hope you got it, guys. Clear? Right. Now, how we need to do the practical session into our laptop, into our virtual machine. Guys, how many peoples you remember how to install the operating system? How many partitions we created at the time? What are they? Did you remember while we installed the operating system at the time, we used manual partitioning instead of auto? We used one option called I will create the partition. Yes, no. So if you use this option, you got a one partition window. There we selected LVM. Did you remember? LVM mount point by default will have their standard LVM thin provisioning, LVM like this will have. Now in this session, we are going to discuss about LVMs and standard. Already we completed standard partition. Today we are going to discuss about LVMs. We selected by default LVM, right, guys? If you select by default LVM mount point, automatically it will create the volume group. It will create the volume group. It will create the logical volume. Now I will show you what kind of like infrastructure we'll have in our hard disk. Let's see, guys, here. This is 40 GB hard disk, right? For backup, we need to take a snapshots. Here we are not going to cover snapshots. Everything we are going to cover in admin course, right? Here, how to create the LVM, how we need to increase the disk space, how to reduce the disk space without losing the file system. I will show you. So for backup and those all, we need to do snapshots. So snapshots, LVM snapshots, video snapshots, and status snapshots, everything we are going to cover in admin course. Okay, right. Assume this is 40 GB hard disk. So while we are try to creating the like a virtual machine, at the time we provided 40 GB. Assume this is a 40 GB virtual hard disk, right? So first partition, actually we'll have two partitions, right? DV SDA1, SDA2. If you want, you can check. I will show you. DV SDA1. So this is 400 MB. 400 MB for whom? Boot. So minimum 200, recommended 200. 200 is enough. But while we are trying to installing the operating system at the time, we provided 400 MB for whom? Boot. Got it, guys? So this is boot, right? Okay. So this is boot. So boot size is 400 MB. Boot size is 400 MB. SDA2 30 GB, right? So in the 30 GB, automatically one volume group it will create, that is called Red Hat, RHEL. RHEL volume group size is 30 GB. Because while we are installing the operating system at the time, we used LVM on point. Okay. By default, one volume group it will create, that is called RHEL. Right, guys? So with the help of this volume groups, we created 3 partitions. What are they? Root, forward slash. So forward slash is a mount point for root directory. Root. Okay. Forward slash, I think we provided 12 GB, right? 12 GB. This is total 30 GB, guys. 30 GB. RHEL is a 30 GB. RHEL is volume group. How we create the volume group here? Like the same way, RHEL is a volume group here. Right? Root, then swap. So for example, swap, I think we provided 10 GB, 8 GB or 10 GB, whatever it may be. Okay. So clear, guys? Swap, usually we need to provide equal to RAM or otherwise double of the RAM, right? Next, one more partition, home. I hope you got it, guys. While you are installing the operating system at the time, so we have like this partitions, because we used LVM mount point. So if you're using LVM mount point, automatically volume group it will create and logical volumes it will create. Home 8 GB, I think 8 GB, right? So let's see, guys, here. So with the help of this volume group, 3 LVMs. Forward slash is 1 LVM. Swap is 1 LVM. Home is 1 LVM. Slash home is 1 LVM. So I hope you got it, guys. Clear? So clear, guys? Yes, no? So this is our infrastructure as of now we'll have into our operating system, into our mission. Right? And remaining how much we'll have? 10 GB space we'll have. If you want, you can verify. Let's see. We have one command called lsplk. lsplk is a command. So I hope you got it online. So this is the infrastructure. That means hierarchy. Disk hierarchy will have into our virtual machine in our operating system. Hey guys, okay, can you hear me online? Am I audible? Right. So let's see here. lsblk is a command. Simple. So it will provide you tree structure. SDA is a device name. SDA1 boot. SDA2 30 GB. With SDA2 we'll have RHEL group. Then root, swap, home. So mount point / swap and /home. And this is SR0 image file. Our image file mount point. I hope you got it right. So total approximately 30 GB utilized guys from 40 GB. Then how much we'll have free space? 10 GB, right? Instead of adding the one more hard disk for doing the LVM practical session, we are trying to creating multiple partitions. We are going to consider one partition as a one hard disk. We have 10 GB free space, right? So from the 10 GB, we are going to create two partitions. We are going to use those both the partitions as a two different hard disks. Clear? No need to add additional hard disk now. If you want, you can add. It's not a problem. I'll show you how we need to add additional hard disk also. Don't worry. So let's see here. So now we are trying to creating one more partition. So you know very well how to create the partitions. So DEV, SDA, SDA3. So 2 GB primary partition. So we need to create more than 4 partition, right? So remaining 8 GB we need to convert into extended. So because we are using MBR partition schema. So here 4 GB. Sorry, partition 4. 8 GB total, not 4 GB. So this is extended, right? And those are primaries. 3 primaries, 1 extended. With the help of this extended partition, we are going to create multiple logical drives. One logical drive is enough. What is the difference between primary and logical drive, guys? 4 GB SDA 5. So like this partitions we need to create. What is the difference between primary and logical drive? Both are block devices only, right? But what is the difference between primary and logical? In primary itself only we can able to install the operating system. So in logical drives it's not possible. Like our HDD, SSD and previous generation in EVS. Everything is block devices only, right? We'll have boot volume and non-boot volume also, right? Like the same way here. So I hope you got it, guys. Very good, Praveen. So clear? So like this partitions we need to create. Now we are going to use this 2 GB as a one hard disk. Okay. We are considering this 2 GB as a one hard disk. With the help of this partition, now we are going to create the LVMs. Let's see guys here. We need to convert the standard partition into PV. PV means physical volume, right? So PV means physical volume. This DEV SDA3 we need to convert into the PV, physical volume. With the help of this PV, we are going to create volume group. Right? Let's see guys here. We are trying to creating one volume group using this PV. So VG, volume group. Now volume group size how much? 2 GB. That's it now. So 2 GB is a volume group size. Because this partition size is 2 GB, the standard partition we convert into the PV. With the help of this PV, we created one VG, volume group. With the help of this volume group, we are going to create LVMs. So it's not like this, you need to create 2 GB LVM. So you can create 400 MB also. Right, guys? Four hundred MB, 500 MB. So maximum possibility 2 GB. So what is the use of LVM? You can able to increase, you can able to reduce. Guys, we can able to increase into any partition. It may be any file system, XFS, ext4. But in XFS, we are unable to reduce. In XFS, we are unable to reduce. But ext4, we can able to reduce. So in XFS, we can able to increase the partition size. We need to reduce in the sense, we need to take a snap, we need to take a backup, the current partition we need to delete, and then again, according to our requirement, we need to create the partition, we need to transfer the data. That is a very little bit lengthy processor. But coming to ext4, you can increase, you can reduce the partition size without losing the file system. Now we are going to use ext4. Right? So I hope you got it, guys. According to this diagram, now we are going to create the LVM. Right? So this 4 GB also I'm going to use, not now, I'll tell you. At present, so try to create the LVMs with the help of one partition. So how to create the partitions? Which command we need to use to create the partitions? Yes, guys. कौन सा कमांड यूज करना चाहिए? हाँ? Guys, 1 minute. Right? Very good. fdisk command we need to use. fdisk dev sda. Got it, guys? fdisk dev sda. Then and to create the new partition. So primary partition, third partition, first sector, don't give anything. Last sector, we need to define the size plus 2 GB. P to print the partition table. DV SDA3. So 2 GB. 83 is a partition ID Linux. Right, guys? This is Linux partition. We need to convert Linux to Linux LVM. Right? Yesterday, Linux partition, we convert to Linux Fab Solaris. While we are trying to creating the additional swap partition at the time. Like the same way, now we need to convert Linux to Linux LVM. How to change the type? T is an option to change the type. To whom? Third partition. right? So hex code, if you don't know the hex code, then use capital L, then it will provide the list of hex codes. So what is the hex code for LVM? 8E, 8E, right? Linux to Linux LVM. So P to print the partition table. See guys, here before we'll have Linux, now it became Linux LVM. I hope you got it guys, right? Clear? Next. Again, we are trying to creating new partition, extended partition. Total free space we convert into the extended. So P to print the partition table. SDA4 is extended partition. SDA4 is extended partition. I hope you got it guys. Then with the help of extended partition, we are trying to creating logical volume 4 GB. So P to print the partition table, DV SDA5 4 GB. But it's a Linux, right? We need to convert the partition from Linux to Linux LVM. So T to change the type. So which partition? Fifth partition. Xcode 8E. Then P to print the partition table. See guys. So I hope you got it. So like this, we need to convert the LVMs. Then W to save. Part probe DEV SDA. Then hit enter. Our hard disk name is DEV SDA. Then hit enter. Right? So how many partitions we created as of now? 5 partitions. See guys here. 3, 4, 5. 3 primary, 4 extended, 5 logical drive. Right. According to this diagram, we created 3 partitions now. Right. Now we are going to use SDA3 partition to create PV, physical volume. So how to create physical volume? PV create is a command. Simple commands, easily we can able to remember, it's not a big deal. PV create, then DEV SDA3. We convert SDA3 standard partition to PV, physical volume. Okay, PV create DEV SDA3. So physical volume DEV SDA3 successfully created. I hope you got it right. Physical volume DEV SDA3 successfully created. Now we need to verify whether the volume is created or not. PVS is a command. PV status. Already we'll have one PV DEV SDA2 that is belongs to operating system. No need to bother about DEV SDA3. DEV SDA3 volume group RHEL and LVM version 2 attributes size and free space. Then here just now, according to our requirement, we created DEV SDA3. I hope you got it guys. So this DEV SDA3 physical volume doesn't have any volume group. We didn't create as of now. Just we created only PV, physical volume. Okay. So whether the physical volume is created or not, how we need to verify? Using PVS command, right? PV display. PV display also you can use. DEV SDA3. See guys here. DEV SDA3 is a path. We doesn't have any volume group. Detailed information you're going to get. I'll tell you what is PE, what is LE and everything. Don't worry. Right? So 2 GB size, and this is a UUID, universal unique ID. Each and every device is having the universal unique ID to identify the device. Right. So now we created physical volume. With the help of this physical volume, now we are trying to creating volume group VG. So simple guys. VG create is a command. So VG create is a command. Then VG name, you can give any name. Okay, I'm providing my underscore VG. Then PV name, DEV Guys, simple syntax. VG create is a command, VG name and PV name. Volume group name and physical volume name. Now we are trying to creating my underscore VG volume group with DEV 3 physical volume. Then hit enter. See guys here, volume group my underscore VG successfully created. VG it got created. How to verify? VGS is a command. See guys, just now we created one VG called my underscore VG. It having one PV physical volume. With the help of this physical volume, we created this VG. As of now, we doesn't have any LVMs. We doesn't have any snapshots, attributes and size. Okay. So this is RHEL. RHEL is a operating system volume group. While we are installing the operating system, automatically RHEL volume group it got created. No need to bother about this. This is related to operating system. Just now we created my underscore VG with one PV. If you want, you can use VG display also. VG display detail information you are going to get. So VG name my underscore VG. So LVM version 2, metadata area, meta sequence area, reader permissions will have resizable. The status, maybe we can able to resize. I will tell you how to resize and everything. Don't worry. Okay. So let's see here. How much size? 2 GB. So VG size is 2 GB. Guys, remember this PE. PE full form physical extents. Physical extents means small chunks it will create internally inside the partition. Chunks means small blocks. So small blocks it will create. Right, guys? PE means physical extents. PE full form physical extents. PE full form physical extents. By default, physical extent size is 4 MB. Remember, why 4 MB? What is the use of physical extents? Everything I'll tell you, don't worry. At present, remember, PE size is 4 MB. Okay. So PE size is 4 MB. Right. VG size 2 GB, right? VG size is 2 GB, PE size 4 MB. Right. So we got a detailed information about our VG. Now we need to create logical volume. We created this partition. With the help of this partition, we created PV. With the help of this PV, we created VG. Using this VG, we are trying to creating LVMs now. Okay. LV create is a command. Logical volume creation. LV create hyphen capital L. Capital L stands for size, length. How much size we need to provide for logical value? Maximum possibility 2 GB. So below 2 GB you can use. So now 400 MB I'm providing. Right? So VG create space hyphen capital L, then 400 MB. Hyphen N means name, guys. Logical volume name. My underscore LV. With whom? My underscore VG. Very simple syntax. LV create is a command. Hyphen capital L. L stands for length. So 400 MB size we provided for this LVM. N means name. So what is, according to your requirement, you can give any name, guys. It's not like this. We need to provide my underscore LV. You can give ABCD, XYZ, whatever. If you want, you can give. So here we provided my underscore LV, with whom we are trying to creating with the help of my underscore VG. Simple syntax. LV create command, -L length, size we need to provide, -N name, logical volume name, and with whom we are trying to creating with the help of volume group. Hit enter. See guys, logical volume my_LV created successfully. Then let's see here how to verify. LVS is a command. See guys here, my_LV is a logical volume. It having one volume group and the total size of the LVM is 400 MB. I hope you got it. So home, root, swap, those all belongs to operating system. Those all LVMs. Home also LVM, root also LVM, swap also LVM. So I hope you're clear, right? Next. So we have one more command, LV display, LVS, LV display, whatever if you want to can use. See guys here, DEV my_VG / my_LV. This is a path we need to store the data. Don't store the data inside the DVSDA3. I hope you got it guys. Don't format this DVSDA3. So यहाँ पे data store करना है तो ये सब कुछ करने की जरूरत नहीं है, right? If you try to storing the data here, why we should do those all stuff here? So here where we need to store the data, if you try to storing the data, you are unable to increase the partition. SDA3 we are unable to increase. If we having the possibility here, why we need to do those all stuff? I hope you got it. Where we need to store the data inside the LVM, not into SDA3. SDA3 is a base, that's it. You're not going to store the data directly inside the SDA3 with the help of LVM. You're going to store the data, right? So where we need to store the data here, DEV my_VG my_LV. This is a LVM path. Here we need to store the data, and LVM my_LV and volume group my_VG, UUID, read and write permissions, operating system details, and availability status. It's available. See guys, size 400 MB. Guys, if we observe current LE, LE means logical extents. PE full form physical extents, LE full form logical extents, right? Logical extent size is 100 now. Automatically got created. 4 into 100, how much? Got it now. 4 is a PE size. 100 is a LE size. PE size into LE size. I hope you got it, guys. No? $40,000 a year, 400, right? So clear. 4 into 100, 400. So what is the meaning of this? 400 actual LVM size. In that 400, each chunk size is 100. Like this, 4 chunks will have 4 blocks, logical blocks it will create internally. Okay. Each block size, each chunk size is 100 MB. Like this, 4 chunks will have 4 into 100, 400. So I hope you got it, guys. Right? Now, so clear? Online, how to create LVMs. LSBLK is a command. See, guys, DEV_SDA3 and my_VG is a volume group. My_LV is a logical volume. Now we need to store the data inside this 400 MB. How to store the data? Yes, guys. How we need to store the data? Yes, guys. So we need to create the mount point, right? Before creating the mount point, we need to assign the file system, right? Because it's a raw partition. DEV my_VG and my_LV, those all raw partition. It doesn't have any file system. Just we created LVM, that's it. We didn't assign any file system. First of all, we need to assign the file system. How to assign the file system? MKFS. Very good. -T. Then XFS. If you want to can provide XFS, but XFS having one problem, you are unable to reduce the disk space. We can able to increase the disk space, that means LVM size, but we are unable to reduce. We need to reduce in the sense we need to follow few procedure. We need to take the snapshot and then we need delete the current partition, again create, again we need to recover the content from the snapshot. Those all stuff we should do. Because of that reason, what we are doing in a sense, we are using ext4, because how to increase, how to reduce, both we can do here, right guys? XFS, NTFS, not XFS. Okay, so clear. ext4 we are using, because XFS we can able to increase, we can able to increase the partition, but we are unable to reduce. But in ext4 we can increase, we can able to reduce the partition size, right? So now dev my underscore vg, then my underscore lv. Got it guys? I hope you got it. So now we assign the ext4 partition, right? So how to verify? How to verify guys? blkid. blkid is a command to know the block id. dev my underscore vg, then my underscore lv. See, got it? This is partition name, LVM name, UUID, universal unique ID, and then type ext4. So blkid is a command, right? Block ID guys, or otherwise lv scan also you can use. All the LVM details it will show you. See, this is a path we need to store the data, size of LVM 400 MB as of now, right? So now how to store the data inside this LVM? We need to create a mount point. Yesterday we created mount point, right? So if you want, you can use MNT to create the mount point, or otherwise you can use your own directory also. We'll do one thing, we'll create one directory. Okay, mkdir, then home student desktop dir1, right? So now dir1 directory it got created. So I hope you got it guys, right? Now mount is a command, then dev my underscore vg, my underscore lv, home student desktop dir1, then hit enter. See guys, one mount point it got created on top of the desktop. How it is looking? It's looking like DVD drive, right? CD drive. But yesterday icon, one solid hard drive. Solid hard drive we are unable to increase, we are unable to reduce. Here DVD, according to your requirement you can play the DVD. Maybe it may be Blu-ray, size is different, normal DVD size different, CD size is different. So I hope you got it, right? So now we are going to create few files inside the partition. Partition means inside the LVM. Guys, you will have last plus found one directory inside the ext4. So this is for recovery purpose. No need to bother about that. Okay, now. So let's see guys here. ABCD, XYZ, file 1, then file 2. Then we are trying to creating few directories. Okay. Got it? Right. So now try to reboot it. What will happen? If you reboot the machine, reboot the machine, what will happen? We are going to lose mount point, right? Just now we created temporary mount point, but we are not going to lose the data. Only we are going to lose mount point. what we'll have the icon on top of the desktop, the icon we are going to lose, but we'll have the data inside the dv my underscore vision my underscore lv. So now how to create the permanent mount point? How to create permanent mount point? Hmm? So yesterday classes you didn't attend, huh? VIM, then Vinay, VIM, yes Vinay, etcfs tab, very good. So we need to edit etcfs tab file using VIM editor. It's not like this. You need to use VIM. You can use any editor. So clear? So let's see guys here. Hmm. Right. See guys, we doesn't have the mount point on top of the desktop. So how to create the permanent mount point? VIM etcfs tab. Right. Inside this fs tab file, we need to add entries. Guys, don't give dvsda3 here. My underscore vg, then my underscore lv, then home, home, student, student, desktop, dir1. Then ext4, default permission, system default permissions. Zero, dumping, zero check sequence. Zero means disable. Dumping and check sequence both be disable. Right, save and quit. Then mount -a to reset. See guys, if you open, then you can able to find the data. So I hope you got it. Now you can reboot. We are not going to lose the mount point. We'll have permanent mount point now. Okay. Mount is a command to create the temporary mount point. So fs tab is a file to create the permanent mount point. Right. So let's see guys here. Oh, so let's see guys, we'll have the partition on top of the desktop. Next. So we are not going to lose the data. Actual purpose of LVM, we can able to increase, we can able to reduce. Now LVM size, LV scan is a command, right? 400 MB. Now we need to increase 400 to 600 MB now, right? So LV extend, LV extends hyphen capital L plus 200 MB. At present we have 400, right? So we need to increase the size 400 to 600. Then we need to add 200 MB more inside the existing disk. So plus, we need to use plus means adding, minus means removing, right? Then to whom? DEV, my underscore VG and my underscore LV. Then it enter. See guys, extending logical volume my underscore LV to 600 MB. If we observe here, it became 600. But if you use this df hyphen capital th command, then what will happen? Let's see. See guys here, still it is showing 400 only. We got increase, but it's not resized properly. We need to resize the disk. Resize 2fs is a command for ext4. If you're using xfs, you should use xfs underscore growfs. If you are using xfs partition, you need to resize. In a sense, you should use xfs underscore growfs. Now we are using ext4, right? We should use this command resize to fs. Okay, according to your file system, we need to use the commands to reset, to resize. So latest file system xfs underscore growfs, xfs ext4 resize to fs, right? Here we are using ext4, right? So because of that reason, we need to use resize to fs, then dev my underscore vg and my underscore lv, then hit enter. Let's check. So approximately 600 MB. Clear? Let's verify whether we'll have the data or not. We have. We didn't lose any data. I hope you got it, guys. So if you want, you can verify like this also. CD, home student, desktop, dir1, then check the list. We have the data. So I hope you got it, guys. How to increase the partition size without losing the file system, without losing the data. Now we are trying to reducing the partition now. Okay. So now it's a 600 MB. Now again, we are reducing 600 to 400. If you want, you can reduce below 400 also, it's not a problem. But according to your data, you need to reduce the size. So maybe if you're having 400 MB data, so if you try to reducing 400 to 300, then you're going to lose 100 MB data, right? So, okay, what we add the 200 MB, now we are trying to removing, we are reducing again. Okay, guys, we need to follow few steps here. Please focus on it. Okay, so increasing, it's very easy, it's not a big deal. Reducing, we need to follow few steps, right? What kind of steps we need to follow? First of all, we need to unmount. Umount is a command, then dev my underscore vg and my underscore lv. You need to unmount. Got it, guys? Unmount it first. Next command, e2fsck hyphen f to organize the data. Got it, guys? So this is a mandatory e2fsck command you need to execute, otherwise you are unable to reduce. Okay, to organize the data, e2fsck is a command we should use. Next, resize 2fs, resize 2fs, then dv my underscore vg and my underscore lv to 400 MB. Simple. It got reduced, right? Resizing the file system on dev my underscore vg my underscore lv to 400 MB. That means it's showing in KBs, MB is 400 MB. Approximately 400 MB will have. Got it, guys? So I hope you're clear. Next, what we need to do? LV reduce. LV reduce hyphen capital L minus 200 MB from. Yes, see guys here. If you're having more than 400 MB data, you're going to lose. Yes, anyway, we need to reduce. Got it, guys? So reducing logical volume to 400 MB, right? Next, mount hyphen A to reset the mount point. See, guys? Got it. So df hyphen capital TH. So 380, 6 key, ఇప్పుడు కాదు 380 MB. I hope you got it, guys. Yes, no, right? So if you want, you can verify data. Home, student, desktop, dir1. Got it? I hope you're clear, guys. How to increase, how to reduce the partition without losing the file system. Got it? Right. So let's see, guys, here. We increase LVM, we reduce LVM. Now we need to increase VG and we need to reduce VG. Right, guys? Maximum possibility. It's permanent only, man. It's not temporary. Even if you reboot the operating system, you'll have 400 MB only. You'll have same data only. Right? Permanent changes. It's not a temporary changes. So clear. Now the size of the VG is 2 GB, guys. Maximum possibilities of LVM 2 GB. Now our intention, we need to increase the LVM size more than 2 GB. Then what we need to do? First of all, we need to increase the VG. That's it now. Already we know how to increase the LVM size, how to reduce the LVM size. Now we are trying to increasing VG size and we are reducing the VG size. How to increase? Simple. We need to add one more hard disk. Simple. This 4 GB partition, we are going to convert into PV and we are going to attach it to VG. Now it became how much? 6 GB. 2 plus 4. Right? How we need to attach this additional hard disk. Like the same way, in future, if you need to increase the size of the disk, then you can add one more hard disk to VG. No need to bother. Simple. Right, guys? So downtime also we doesn't have. So let's see, guys, here. PV create, if you want, you can create, or otherwise directly can add. VG extend is a command. VG extend, VG name, then new PV name. Actually, PV name we need to provide. Okay. Automatically it will convert PV. No need to create the PVs. While you are trying to attaching this volume to this VG, right? Automatically DV SDA5 it will create PV, then it will attach to VG, right? So let's verify VGS. See, guys, here 2 PVs will have. Let's verify PVS. SDA2 it belongs to operating system. SDA3, SDA5 those belongs to my underscore VG. SDA3 2 GB, SDA5 4 GB, 2 plus 4 6 GB. Now size of VG is 6 GB now, right? But here we are utilizing the LVM from SDA3 itself only. LVM will have, right, LVM infrastructure. This LVM infra we are going to utilize from SDA3 itself only. But VG size it got increased. If you want, you can verify VG display. See. I hope you got it, guys. How to increase the VG size? It's a very simple. VG extend is a command. How to reduce the VG size? Now we'll have SDA3 2 GB, right? We need to remove the 2 GB. We need to keep like new volume 4 GB, right? 2 GB we need to reduce. Total 6 GB will have, right? We need to remove the 2 GB from VG. How? Let's see here. PBS is a command, guys. DVSDA3 it's in use, right? Because LVM infra, LVM everything will have inside the DVSDA3. We need to move this LVM along with the data from SDA3 to SDA5. I hope you got it, guys. This LVM we need to move from SDA3 to SDA5, then only we can able to remove the SDA3. How to move? PV move is a command. Physical volume move. DV SDA3 to DV SDA5. So I hope you got it, guys. Right? This is called migration. We are migrating one PV to another PV. LVM. We are trying to migrating LVM infrastructure from one PV to another PV. So clear, guys. Let's check PVS. See, guys. Now SDA3 is free. So we have an LVM and data inside the SDA5. Now we can able to remove this SDA3. Okay. How to remove? VG reduce, VG reduce. Guys, don't use VG remove, okay? VG reduce is a command. Then my underscore VG. Then to whom we need to remove? SDA3. See, removed SDA3 from volume group called my underscore VG. PBS. See guys here, we doesn't have any volume group for SDA3 now. Got it? Then VG display, it became 400 MB. So guys, we have the data. We doesn't have any problem with the data. See, if you want, you can open. We are not going to lose the data. Right, guys? I hope you got it, right? Clear? How to reduce, how to increase the volume group. Anyway, we are unable to increase the VG. If you're able to increase the VG, why we should do those all stuff? Sorry, PV. You are unable to increase the PV. Right? So clear how to increase the LVM, how to reduce the LVM, how to increase the volume group, how to reduce the volume group. We are unable to increase the PV's physical volume, right? Okay. Now, how to delete, we'll see. Okay. Guys, first of all, you need to remove the FS tab entries. Remove those entries from FS tab file, right? Unmount it, right? You need to unmount, right? Now you can delete. LV remove is a command. Then DV my underscore LV remove is a command. DV my underscore VG and LV. Yes, always we are going to lose the data as we need to provide. Now LVM it got deleted. VG remove is a command. Then VG name. Then VG it got removed. PV remove is a command. How many PVs will have? 2, right? DV SDA3 and SDA5, right? Both it got wrapped. Let's check LV scan. V doesn't have any LVM. Now it got deleted. So clear, guys? I hope you got it. Then go to FDisk, delete the partition. That's it. FDisk and delete the partitions. So clear. This is all about LVM. Actually, we'll have an interview point of question. We'll do tomorrow. Okay. Interview point of question we'll have related to LVM. We'll do tomorrow after completing LVMs. We are going to hardly, it will take 10 to 15 minutes. Okay. Then if you're okay now, then I will teach you. Huh? Okay. No. Why? Huh? Class on the ingot. The new building, huh? A building. Manjira Square. Huh? Right. Yes, guys, if you're having any doubts, any questions, please. Please. If you're having any questions, any doubts, huh? Link. Still you are asking about link, huh? So we are going to complete the session maybe within a 10 days. And then still you are asking link. I don't know, man, what you are doing, Nagireddy. You are asking about link. right? Yes, guys, if you're having any doubts, any questions, please. Yeah, bye, Nagredi. Okay, guys, see you tomorrow. Bye. Take care.